So, building off of what our warm-up was today, a compound inequality is really just two inequalities put together. That's what it says here. It's two inequalities that are joined by the word and or the word or. So we're going to go through an example of using the word and as well as using the word or. You can see right here I've already graphed x is greater than or equal to -5. Also on the same number line we're going to graph x is less than or equal to 1. So I see I have a solid dot at 1 because it can be equal to 1. And we're going to shade to the left. Now the word and, what that really means is that both of our inequalities have to be satisfied. We have to pick the numbers where both of the inequalities are going to be true. So we know that it can be equal to -5, it can also be equal to 1, and it'll be everything in between. Really, it's just where both of those lines intersect. And whenever we're using the word and in our compound inequalities, our graph is going to look like 2 points connected by a line. Now the points don't have to be solid like this, they could be open or solid, but almost always when we use and, it's going to look something like this when you graph it. Now the or is kind of the exact opposite. So instead of the intersection or where both inequalities are satisfied, either of them are going to work, or either of them will make the statement true. So we have x is less than 2, we'll have an open circle at 2, and go to the left. Or x is greater than or equal to 3, we have a solid dot at 3, and then going to the right. Now, unlike the inequalities with and, you can see how in this one there's actually nothing that's intersecting. So for or, it's even simpler. All we really have to do is graph both of them separately. So when dealing with or, it's almost always going to be two separate inequalities that we're using to either graph, create, or solve. Now we're going to look at a couple examples. So, how do we write inequalities? Well, from these word phrases, we can know that we create something that's at least -2 and at most 4. If you want to think about it graphically, so we're going to be at most 4 and at least -2. So as I was saying before, we're going to start at each of these points, and it's going to be everything in between there, right? It can be at least -2 or at most 4. You have to ask yourself, can it be -2? Well, if it's at least -2, it could be at -2, so we have a solid dot. It's at most 4. Well, it certainly can be 4, so it's going to be another solid dot. And that's what the graph would look like. Now, how would we write it? Again, you can write it as two separate inequalities. So we would have x is at least -2, so it has to be greater than or equal to -2, and x at most 4, so x has to be less than or equal to 4. Now, whenever we're writing compound inequalities with and, you can also write it as one longer inequality. So you see with the picture of the graph here, all of our values for x are kind of sandwiched in between -2 and 4. So you can actually write the inequality with a -2 and a 4 and x sandwiched in the middle. Our symbols are going to follow the same. So just like right here, the x is less than or equal to 4, so less than or equal to 4, as well as right here, x is greater than or equal to -2, well, we just have to put the greater than sign on x. And so you can also write your compound inequalities with and as one longer statement like that. Again, using a more concrete example with temperatures, if today's temperatures will be above 32 degrees, so we were just to write a compound inequality, x, the temperature, would be above 32, so greater than 32, but not as high as 40. So then also x, not as high as 40, x has to be less than 40. And again, since both of these have to be satisfied, they're joined by and. X is greater than 32, x is less than 40. It does say graph the solutions. So we'll write a 40 up here. I'm going to jump by 2's just so I don't have to write all the numbers. Oh, I need one more here, 32. And we can graph it. X is greater than 32. So it's above 32, so everything above 32, but not as high as 40. So when we get to 40, we have to have another open circle there. Looking at our next example, now we're going to have to solve our compound inequalities. So when solving, you can see how what they have written here, -4 is less than r minus 5, less than or equal to -1, is that one longer compound inequality we were talking about with and. So there's two ways you can solve these, which this is what your homework is for tonight. You can split it up as two different ones. So you can do -4 is less than r minus 5, and r minus 5 is less than or equal to -1. So you can certainly split it up into two inequalities and solve each one individually. So we would add 5 to both sides. And then you're going to get over here, we'd have -4 plus 5 is 1, is less than r, because -5 plus 5 is 0. Same thing over here, we're left with r is less than or equal to 4. Now we can see that our solution is going to be 1 is less than r, and r is less than or equal to 4. Now, how would we write this as one longer inequality? Again, we just have to sandwich the r. So we can do 1 is less than r, which is less than or equal to 4. The other way to solve these, you can see how in this step right here, yeah, I solved them both individually, but I also kind of did them both at the same time, because all we did is add 5 in all of them, right? So if we wanted to, we could go back to the beginning and just add 5 to all three parts. And then we're going to get a 1 here. We add it so the signs stay the same, and r, and then -1 plus 5 is 4. You see how we get the same answer either way. Might be faster to do it the second way, but if it makes more sense to you, you can do it the first way. Now, example 4 here, we'll write a compound inequality that represents each situation, graph the solution. So all real numbers that are less than -3. So again, we have x is less than -3, or greater than 7. So x is greater than 7. Now, in order to graph that, we're going to need a longer number line. So So if we start down here at -4, -3, I'm going to start skipping so that we don't have to write every single number as long as the tick marks represent the same amount each time. So you can see how x is less than -3, so that's an open circle and to the left, or x is greater than 7, open circle to the right. And really, remember from that first example, whenever we're graphing the or, you just graph each one separately. So once again, we'll do part B here. Discounted fares are available to children 12 and under. So discounted fares, x, are available to children 12 and under, so x has to be less than or equal to 12. Again, they use the word or, so we're going to also use or to adults at least 60 years of age. So x, they have to be at least 60 years, x has to be greater than or equal to 60. Now, I'm not going to go ahead and graph this one because we'd have to skip a lot of numbers. Moving on to the next example, last one. So we have to solve an inequality using or. Just like when we were graphing them, solving these, you just treat it as two separate inequalities. So there's one, we have or, -2v plus 7 is less than 1. And we just solve them as two separate inequalities. So here I'm going to subtract 3. So then I get 4v is less than -8. And then you can divide by 4. And you get v is less than -2. Again, solve them separately. We're going to have an or right here. And we start solving this other one. So -2v plus 7, I'm going to subtract 7 on both sides. You get -2v is less than -6. Now we'll divide by -2. And you get v. Now we divided by a -2, so remember that sign is going to flip the other way. And v is greater than 3. So, graphing it, I'll start at 0 right here, -1, -2, -3. So we can see that v is less than -2. Simply open circle at -2 to the left, and v is greater than 3, open circle at 3 to the right. So really, whenever there's an or, you treat it as two separate inequalities. You just have to graph them on the same number line, or join your solutions at the end by or. Or, if we're going back to the ones with and, remember, you can do it all in one step as long as you add to each part of your inequality. As long as we solve and do the same steps for all three parts, we can do it in one step, or you can simply also split it up like we do with the or.